This conference will now be recorded.
So we have given you very limited time, but yeah, that's a thing. That's a way we have to, learn faster and better. So, what is Kubernetes? So, if you really want to understand Kubernetes, you have to understand limitation of Docker. Okay, limitation of Docker. Now, what is the limitation of Docker? That let's discuss about it. I'll put it in a simple way. So let's say there is one host and you have installed Docker inside this. Docker is managing multiple containers. Yesterday we discussed. Now maximum the container what you can run in Docker in the host would be 3. So if I want to run more container, what I would do? Tell me what I would do.
Didn't get your question, Rajesh.
Yeah, Rajesh.
See, I have one host. Docker is installed. It's running 3 containers. Maximum the 3 containers I can run in that particular host. If I want to run more container, what I would do of the same application?
More server.
More server. Simple logic. We'll have a more server. 1, 2, 3. So the question is very simple. Docker can manage the container. Now the question is very simple, and that is, who will manage multiple Docker host? There should be management tool for the managing multiple Docker host also, right?
Yes.
Yeah, got it. So one of the reason, if someone is saying, hey, why we are using Kubernetes, then what would you say? What would you say? So
it is to view.
It is
Should
to
I
manage.
Managing the containers.
Deploy our application into some microservices. Divide the microservices.
So you can say something like this. Container is a love for every developers. It saves lots of time, lots of efforts, environment creations and all. It's just a matter of second. Everyone loves container, but container is not good for running the large server. A Docker is not good for the running the container at the large scale in a data center, because Docker can manage a container, but if you want to run container in the hundreds and hundreds of hosts, then we require some orchestration tool we call it. Okay, so that is Kubernetes. Kubernetes can manage multiple Docker hosts. The Kubernetes can manage the orchestrate the entire infrastructure which is in the container environment at the large scale. Getting my points, all of you?
Yeah, Rajesh.
Can you reframe the definition, right? So it will be helpful. Like,
if you want to put it in one go, container orchestration is done by Kubernetes. Container management is done by Docker. Got it? Orchestration means?
Got it.
Yeah. So this is the one reason. This is called scalability. Container cannot scale beyond the host. So with the Kubernetes, it can scale as much you want. That is one. There are lots of other reasons. This is a fundamental reason actually. Second reason which you say, let's say there is a 3 containers and these containers died because of some reason. This host itself died because of hardware reason, software reason, network reason, this region, that region. It may happen. So if this, let's say your whole site is running with a 9 container and your response time is 1 second for the current traffic. So if the 3 containers is died, then what will be the problem? One host is disappear. What will be the problem? All of you?
Some
Let's
dependencies
start.
will be miswrite like
Next,
for the application.
next input.
The
Next
data which
input.
has
Like
been worked will be lost.
Data will not be lost for when
Data in
you
the sense,
go.
the work, all what we did will
No, no,
be.
no, no loss, no loss. When you design a production level, no, then those are the things we take care of it. Even though half of the data center gets disappeared, don't lose worry. So the only fact which I can see here is, so there's some noise coming from the background. I guess I don't know from where. Bharat is coming from you. I'll mute yourself. Yeah. So only the problem which I see is earlier we had a n number of traffic which was on a 9 container, and now same traffic I have on a 6 container. Same traffic we have on a 6 container. Okay. So response time for the customer has been increased. That is the one problem which I see. And when the response time for the customer hasn't been increased, they usually stop using your applications. Are you getting me? Are you getting me? All of you?
No. Can you please?
Okay, I'll put it in a simple way. IRCTC website. Anyone have tried the Tatkal ticket?
yeah, Rajesh.
Yes, Rajesh.
So when you browse the IRCTC in the non-Tatkal hours and Tatkal hours, what is the problem for you as an end user?
Yeah, there will be no seats, right? So waiting list will be there, and
Error will be there, timeout issues will be there, right?
yeah.
Your transaction will be declined also. Your session will expire. So many issues come. Why only during the Tatkal hours? Because they cannot hold that much of traffic effectively. So same case here. You were running at the traffic at the 9 container. Suddenly it got reduced to 6 container. What will be the user impact? Response time will be increased. Your customer will start complaining about it. The server is not accessible. Services are not good. This is not true. Correct? So now the question is, how can you automatically, I said automatically, please mind it. How can you automatically replace these 3 containers to working servers? How can you do that? Can you, if you want to do that again, you have to 3 o'clock midnight, you have to get up, do some stuff. It might take an hour, 30 minutes or something. Can we have a magically replace the moment this got disappear? Replacement container is in place automatically. Is it possible?
Yeah, auto
So yeah,
scaling.
so that is a question mark. Who can do that? So Kubernetes. Okay, so Kubernetes can help you to manage the Docker host, multiple Docker host. Management capability brings it. Kubernetes can also manage your desire. You desire as admin, you desire 9 containers. Gone, 3 is gone. Immediately they will replace with the remaining 3. So your response time, the customer experience is not never bad. Okay. Third thing is like a networking. Let's understand the networking. There are many reasons for Kubernetes, but only 3 reasons I'm talking about. So guys, let's say this is the 2 container of Apache. Now let me put it up in this way. This is a load balancer. So load balancer will balance. For the load balancers to work, you need a same port number, IP address can be differ. Correct? So you need a same
Yes.
port number and IP numbers. So now here you tell me, can this load balancer can access the container this and this? So this one, in the Docker I did not talk about it yesterday because of limitations and all. but many topics which we could have it, but right now. So though I don't know how many of you have knowledge about the Docker, but this container you cannot access directly out of host. So you can do the port forwarding actually. Have you heard about the port forwarding concept? Yeah, Durga, I can hear you.
Yes.
Yeah. No, Durga,
Rajesh,
your voice.
hello.
Yeah, yeah.
Uh, Durga Prasad sir is unable to talk. It seems. Is there any? He was even asking about that. Is there any issue with that?
From my side, if I can hear you, you can hear me. That means there's no issues with the GoToMeeting. Maybe
Yeah,
some problem with the this one. What to say? Devices or something. Okay.
yeah.
Yeah.
And I didn't get you about the load balancer also. If you could explain that, please.
Load balancer. Okay, we'll talk about load balancer in one of the cloud session. But at a high level now, this is a end user. They connect to the load balancer. A load balancer balance the load and transfer the traffic. Only redirect the traffic to one of the node which is working. So here it's not a node, it's a container.
Okay.
Okay.
Yeah,
So load
I got
balancer
it.
is one software actually. Okay.
Hello.
So yeah, tell
Hello,
me.
Rajesh. Am I audible now?
Yeah, very much. Yeah.
Yeah, earlier I was speaking and seems like my voice was not reached out to you.
Yeah.
So I was asking some doubts. So
Yeah, please
I
tell
can
me.
be able to hear you all guys, but that is the reason I called funny. And yeah. So regarding with this, the Docker and Kubernetes, what you're telling. So I
Hmm.
didn't get uh, uh, to understand how this the first, second, third Docker systems you have written, and then three of them you have disconnected, and the three you are trying to place it in the other hosts, right? are
Yeah, yeah.
these the new are these the new setup of containers you are placing, or the there are three, right? So on top of the three you are trying to do something, so that clarification I need.
Uh, okay, so I have to go back to against the
Yeah, I
position.
didn't understand that. I didn't
Yeah, yeah.
understand that. If you could please start it from the middle or somewhere. I stuck there and I was
Hmm.
asking. So,
Okay, so first thing, you understand the Docker and container concept, correct?
right, right.
Yeah. Now, Docker, I'm not using the same statement as I used before because other people will feel little outdated. But yeah, I'll use add some more points. Okay. So first thing, we use the Docker in a development environment. Okay. When we want to create applications, you might have seen yesterday within a second, you will get Apache, MySQL, Tomcat, Java, Python, Perl, Ubuntu, whatever you want, you can get it in a second. It was like love. I want anything. I don't have to struggle for a whole day. Just Docker run, dab, and you got it. So that is okay for you, right?
Yes, yes,
Yeah.
yes.
Now, you know what? People fall in love with the containers. So they wanted to run application in the production servers also. Production servers, remember, the place where we don't run one application or two applications of instance, we run hundreds of Apache, hundreds of Tomcat, hundreds of MySQL, hundreds of Java, like that. Are you getting what?
Right.
So here, what I was talking about is in the production server. Today, you have to make yourself as a ops engineer, not development or uh, build and release or something like that. Bring it in their shoes. Because you think you want to manage the entire production servers, the operations. So in the operations, what we do, if you want to run a container at the large scale, scalable level, that means it should be scaled to thousands of container, 1 millions of container. It can be. So how do you do that? So that's the problem. So Docker efficiently can manage the container in each host, but you can't run all the container in one host, right? Correct, no?
Right.
So for that, what you will do? You only, I think someone suggested add more nodes. Simple. So okay, you will add more nodes, but in a production you have a 200 nodes and you are the only person. So how can you manage these 200 nodes? So there's a one management capability required, and that is where the Kubernetes is coming. And Kubernetes is saying, hey, let's do one thing. I will manage this host 1, 2, 300 and 1,000 hosts, and I'll take care of this entire orchestration process. And you, whatever you interact with me, and I will interact with all these servers. Make sense?
Mm.
So you alone single-handedly manage the entire operations. Okay, understood?
Yeah.
Second thing is, I said, see, in the data center, some nodes may fail. Why it is failing? That is out of discussion. It is failing. It will fail. It is failing. It will fail, and we have to design the fault tolerance. So that is what I was talking about. Let's say if you have some nodes which got failed. Failed means that those containers also is gone. So now the impact, what would be the impact? The impact would be the immediate impact. Your response time for applications for your customer will become higher, because earlier you had a 9 container as per the image. Now you are having only 6 containers, same traffic. So response time will be higher. Your customers will not be happy about the experience with the applications. So what you will do? You will say, okay, I will go here, set up one more container here, also set up, add one more, set up one more container. Correct? All these things. Correct now? And
Yeah.
maybe after 1 hour, the load will be matched. But
Yeah.
why
And
we
this will happen only when the high availability is not there.
availability is not
High
there?
availability, yeah, that means when the primary, say whatever the data center you are, removing the fault containers, and those
I'm
containers,
not
yeah, when
removing. I'm not removing.
I mean
Automatically
they
it will get removed.
yeah, I mean to say that can you name those all the hosts so that I can talk? One, two, three. So the third container, I mean third host has three containers, right?
Right.
One, two, three. Yeah. So when these containers, three containers were there in this host. So when these three containers have, lost, there might these, for example, say these are the primary containers. There will be some backup containers as well, right? So when
No,
these
no, no,
primary
no, no, no,
containers,
no, no, no,
okay,
no. Production, you never have a application runtime backup. Understand this way. Uh,
okay,
Understand this way. It's very costly affairs. Okay, if you start having a backup server for everything, it's not happening
hmm,
like that. So in the production, backup concept is not there. That's the reason high availability concept is there. So backup concept is like there's a two kind of application. One is the static applications, the and another one is dynamic applications. Dynamic applications like a database, which is keep changing. Okay, so that you don't have a backup for that one also. You create a clusters of database. Okay, and that is what we have in application side also. We have a clusters of applications. So there's no primary backup that you design during the deployment process. If you're using Canadian blue green deployment or something. Okay, so that is
hmm.
a production. If you try to replicate everything as a backup, then you are running the data center at 100 rupees, it will become a 200 rupees, and that's a huge cost actually.
Mhm. So what happens like when these fails? So when these
See,
containers fails, you are saying that the traffic is increased, right?
no,
So the
so
traffic
see,
will only increase when the people will connect to another one, two hosts, right?
no, 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 no.
There are two more hosts, one and
Wait,
second,
wait.
first and second. Yeah.
I never said traffic is increasing in this discussion. I only said your response time will be high.
Yeah.
That
Response
is the
time to whom? Response time to users, right?
end users. So there was
So
let's
end
put it.
users, Yeah. So end users who are contacting to this containers, right? I mean the applications inside the container. So how does this, the third one system, first, second, and third system, when the third system fails, it connects to the second system or say first system, right? Automatically.
Okay,
Yeah. When the
so
third system fails.
okay, I'll put it in a more basics way actually. Okay, I'll go back to the fundamental. For time being, you forgot the container. Okay,
Okay.
please keep out this container out of this discussion right now.
Mm,
See here, right now, if you see that this is my 3 server for time being, in reality there will be 200 servers. Okay, these are the virtual machines. Okay, are you comfortable?
yes.
Now what we will do, we'll create a load balancer here. And here we set these 3 machines to the load balancer. And here the load balancers will map to the DNS server. DNS server means www.devschool.com. That's a DNS server. And DNS server will be hit by end user. Are you agree with me?
Right.
Yeah. So here I mean, think about, you are not software engineer, you are an end user. You hit
Mm,
the www.devschool.com, transfer to the load balancer, and load balancer transfer to the, let's say, Apache server. In the backend also multiple layers will be there. I'm not complicating too much. Okay. Okay. So this is the primary things. Now there is 100 traffic is coming and handled by 3 servers right now. Okay. And my response time is 1 second. Now just imagine one server get disappeared because of some reason. So now the traffic will be load balanced only on the 2 server, this one and this one. That means this load balancer will detect this server is not accessible. So okay, so I'll load balancer will transfer the traffic only to this 2 server. So what will be impact? That's what I'm saying. The response time. So earlier 100 people, 3 server, response time was 1 second. Now 100 people, 2 server, response time will be more, 1.5 seconds. This is what I'm telling you. Getting your points
Yeah.
now?
Correct. So the response
Yeah.
time is got increased. But what is happening at the background? Say for example, I am there, right? So I was trying to contact to the application which is there in the third server, right?
This is
Which
this
is
is
there in the
admin. This
third.
this is operation. Tell me.
Yeah. I am trying to connect to the third server, right? And the third server got disconnected. So
Right.
whatever the application I am trying to connect to the third server, I have now forwarded to first or the second one, right? Through the load balancer,
Yeah. Yeah.
right? Right.
Hmm.
So that means my application is now present in one or second, the first host or in the second host, right?
True.
So when this third server has my application, then the application which I'm connecting to first or second, when third one was down. So how that happened? Is it called high availability or is it called a backup of this third?
Okay. So I'm okay. So now I have to find out the new word to explain. See, you are questioning how the traffic is transferring. I'm saying load balancer will do that, no?
Okay. No, that is fine. I understood, Rajesh. This concept I understood, but the only thing is, what I am trying to understand is there are the applications which are running in the host, right? That those are containers, say for example, and
No, no,
if
forget
the
about the containers.
container,
No, forget about the
okay,
containers. I don't want to talk about
okay,
containers right now. Fundamental,
okay.
we have
So
to be strong. So
yeah.
here in
So
this,
that application was running in third host, right?
huh?
And that
And
application got,
this is down. This is down.
yeah, that is down means entire host is down, right?
And this one only this host is down. So still the load
Yeah.
balancer will balance the traffic with these 2 hosts, no?
Right. So whatever the traffic is coming, that load balancer will try to forward it to first or the second host,
Wonderful.
right?
Yes. Yes.
So now the user, will he connect to the application or not? Uh, just I'm trying to, will he contact that application or not?
Sir,
Will
could
he
I
lose the will he
Yeah. Go
lose the
ahead.
connection? Will he lose the connection to his application?
sir, could I interfere
Yeah.
for
Yeah.
your
Please go ahead.
clarification? Durga sir.
Yeah,
Hello, am I audible,
yeah,
sir?
yes.
Sir, sir is like to explain that in general, due for a Tatkal ticket, non-Tatkal hours, we need a three servers only, virtual machines. But if the traffic suddenly increases, then we cannot keep in the mind that in Tatkal hours there will be more traffic, so that we should manage multiple virtual machines. It will lead to excess cost. So, in order to eradicate that, Kubernetes had came with a concept called as replicas, where it makes sure that
Okay, so I
inside
think,
the
yeah, I'm sorry to interrupt you. Yeah, maybe Durga will get more confused actually. So for time being, let's give a pause to this stuff. So Durga, your last question was, so let's say this machine, this applications got deleted. So will that your end user will get disconnected? What is your question?
Yes.
Yeah. So you tell me where we are connecting. Am I connecting directly the applications or load balancer?
I'm connecting to the gateway first and then the load balancer and the load
Just
balancer.
that's all.
Yeah.
Load balancer.
And the yes, and the load
Ha, ha,
balancer is providing the way towards to go to one or the other by checking the load.
application.
Yeah, by
Wonderful,
checking the load. By checking the
wonderful. Yeah,
load.
yeah,
Yeah.
yeah, wonderful. So
So
here,
yeah,
see,
yeah.
understand
So
this.
here, yeah, yeah.
Just give me a
Along
second.
with
Give me a
this,
second.
okay,
Give me a
okay.
second. Give me a second. Give me a second. Let's one question at a time. I think we are getting into the architecture discussion. So here we need to detail study a little bit of architecture. How do we design it? So actually what happens when we say connecting to the DNS to load balancer, and load balancer has one property which is called health check. Okay, health check. So that means if this node is not, see, remember that you do not hard code this statement in your mind. You do not attach to the application server. What happens? One request will happen from this, another request will happen from this, same login session. I repeat, same login session. Third request will happen from this. Let's say login you happen through this, registration you happen from this, and dashboard you are seeing from this. So, I mean, it's a huge discussion actually. Just to answer your question, if if your server is disappeared where you are initially last time you access, load balancer will give you the similar server, not a same server. I repeat, similar server, not a same server. Now next question you may be having, what about my login session? You know, when you design, so login session is managed by login session server actually. That's a separate server which is not getting destroyed. They also have a multiple clusters of session server. So right now, my discussion is not around that how to design the services, how to design high availability, scalability, reliability, fault tolerance, make sure that some of the services are stateful, some of the services are stateless, some of the communication method. Your question is towards that one only. Okay, that is not my question, but just in straightforward fashion, I was putting blunt way, so we don't need to go into the design discussion. Okay, so here my question was very simple. My scenarios was very simple. My question was, what is Kubernetes? That is what I was trying to tell you. And then if you want to know the reason of why Kubernetes we are using, you need to know the limitation of Docker. And in order to understand the limitation of Docker, I was telling it to you this requirement. So we somehow got diverted into different requirement. Okay, so can we keep these two topics aside right now? Maybe Durga, you can call me for one specific session where we'll discuss the design itself, how to design the application stakeholder. Make sense?
Yeah, yeah, yeah.
Yeah. So right now my question was very flat, guys. Very flat. Let me redraw this picture. Uh, this is the one machine. and I had a multiple containers inside this, 1 and 2, 3 containers. But in data center, we wanted to run multiple containers. Docker was not allowing to manage, so I wanted to manage multiple Docker host, 1, 2, 3, 400, whatever it is, and Kubernetes allows me, Kubernetes manage all the Docker hosts. I don't have to do manually. All this work is done by Kubernetes. So first reason we understood. Second reason which I was trying to tell you is, let's say this machine got disappear. Okay, again, forget about that. What could be the reason for it? This got disappear. So earlier my desire was 9 containers. Simple. I'll not put more design also. I'll not get into that topic right now, because once we learn the platform, then we start about the scalability, reliability, high availability, fault tolerance. All these discussions is good when you understand all the technology. Okay, so right now my desire was 9 containers, but actual how many containers you are having? 6 containers, correct now? All of you. So that was my desire. My manager said, forget about the end user scenarios right now. My manager said, Rajesh, you need to run any given point of the time 9 container. But because of some reason, now it's running with a 6 container. My production is running with a 6 container. So what you will do to make it 9 container? So you will get up around 2 o'clock morning, P1, L1 call, L2 call, L3 call and all, and you will add one more host, and then you add 3 more containers, correct now? That's the first thing you will do. Or you will say, okay, let's do one thing. This is having CPU and RAM available. Let's add 2 here and add 1 here. Tell me, would you do this or not? Or would you do something else?
We would do this one.
Yeah, but
Yes.
guys, for this it required 20 minutes. 20 minutes you required, but your manager say, no, I cannot wait for 20 minutes. You have to get it done all this in 1 second. I repeat, you have to get it done in 1 second. Can you do that? Human can do that?
No.
No, that is where the Kubernetes will need actually. That's the second requirement. You wanted to know why we need Kubernetes. So Kubernetes automatically heal, auto heal functionality it has. How it works, forget about it. But it has it. Auto heal. I'll show you that feature. Okay. So Kubernetes has an auto healing functionality. So here you don't need anything. Automatically 3 container is missing. 3 container will be replaced with immediately with a blink of eyes. Blink it. Maybe we are advertising Blinkit. Are you understanding? Second use cases of so Kubernetes can manage multiple Docker hosts. Kubernetes can manage the desire versus actual, okay, within a second. And third problem which I wanted to tell you, the networking problem, which I'm ignoring right now because I don't want to confuse you people. You get comfortable with the platform first and then start talking about the new advanced feature. But for the sake of discussion, I must tell you here, Kubernetes can help you for the load balancer. Kubernetes help you for health check. Kubernetes can help you for the storage orchestration. Kubernetes help you the network orchestration. Kubernetes can help you for security orchestration. So in a nutshell, everything you can get it at the Kubernetes. It's a platform now where you run pre-production, production, and everything, and all the features you have at Kubernetes. Slowly you will get into that. Okay, so at a high level, at least a 2 region you have for using the Kubernetes. Make sense? Hello?
Yes, Rajesh, we
Okay.
got you.
Yeah. So now guys, I have around 2 hours of discussions in my YouTube channel about why Kubernetes. So this channel, you can check this out. Only for why part, I gave the 2 hours of lecture, which you can in detail, not now, you lose interest in the very complicated topic. First start enjoying the platform and then we can get into that. Okay, so why Kubernetes we understand, but you know what guys, this tool is written by from Google, donated to CNCF. Now anyone have idea what is a CNCF?
No, Rajesh.
So
Container
CNCF,
native.
true, container native cloud foundation. So many products you will be learning from the CNCF. For example, Kubernetes from CNCF, Prometheus is from the CNCF, etcd from the CNCF, Helm is from the CNCF. Many products they have. You must go to their website and see their product catalog. So CNCF is a foundation. It's like Apache. Okay. So new generation software they developed and they drive all this initiative. Okay, so this is from Google donated to CNCF. This tool is written in Go. So if you want to customize it, you have to do the work in Go. Okay, so latest version, if I see, which I'm having is 1.24 if I have a good memory, because every month we have a release actually. Okay, so this is the version which we have it. Okay, so overall, yeah, at a high level, we understand Kubernetes. And now we'll get into the installing Kubernetes. Okay, so any other questions which you have so far?
Till now, till this point, though, I don't have any issues.
Okay, so guys, how do we? Yeah, tell me.
Rajesh,
Going to
one thing. Can you go to that image once? I just want, yeah, backside image.
Yeah, yeah.
This Kubernetes will heal automatically the lost containers, right? So do we need to say where it has to go and do that, or will it
Okay.
automatically find out the hosts for the place where this containers to be created?
Yeah,
Which one is
good
correct?
question. Good question. So first of all, let me put it in this. When you say auto healing, we probably I did not put the right context. Auto healing means please hard code this statement. Here, containers life is not important. Okay, containers life is not important. So when I say auto healing means they will replace with a new container, not they will heal the same container. So I'll put the right word actually. Kubernetes will give you similar container, not the same container in case of failure. Similar, not same. Okay. Second thing, Kubernetes will identify their own host where the space is there, CPU is there, RAM, and Kubernetes has an inbuilt capability to place those containers. Okay, so that is the thing. Did you understand that?
Yeah,
And
yeah,
one
got it.
small doubt, Rajesh, in the same image, one of the container, if you see the third container where all the containers are getting closed, like they are getting failed,
Yeah,
and we are replacing that with first and second using Kubernetes. How does this
correct.
Kubernetes know that so and so server is gone and only these have to get replaced? Is that even automated
Huh.
or?
Even that is automated. That's the beauty about the Kubernetes. So Kubernetes has a, if you get into the Kubernetes architecture at a high level, I'll discuss today. Okay, if you get into the architecture, Kubernetes has all possible components. That's what I said. No, I'll put it in a simple way. Kubernetes is a platform where you get all these features, what you can imagine even, and not even imagine. You get all these features, and all this can handle by only one person. So in the operation, you don't need too many people. You set the desire properly, and Kubernetes will do everything. So yes, those are the features which you are talking about. How do Kubernetes know? Kubernetes knows everything which is you are running in the Kubernetes in a simple way. And the Kubernetes is like a genie. Okay, so genie is controlled by Aladdin only, right? So you are the Aladdin, and Kubernetes can do a lot of things. So I just use the keyword which is called actual and which is desire. So desire will come from you to Genie, Kubernetes. And Kubernetes responsibility to make it actual versus is equal to desire. That's a job is being taken care by the Kubernetes, not by you. So you desire, Kubernetes will give you the same actual. If there is a mismatch, Kubernetes will this heal also and match the desire within a second. So that's kind of capability what Kubernetes has. That's the reason every organization is loving about it, right? Okay, so right now we are only hearing the theoretical part of it. once we start getting into that and start seeing the feature, you'll start probably visualizing more. Make sense?
Yeah, Rajesh.
Okay, so installing. So next topic is installing Kubernetes. Now, Kubernetes architecture, this topic I'll discuss after installing it. Okay. Now, and let me tell you here, guys, many topics I might not probably discussing in depth, because typically it's Kubernetes itself. If I cover Kubernetes topics, okay, it's a 40 hours of course actually. Okay, but right now we have only 8 hours, so I'm thinking in my mind which is most important, let's cover, and which is least important, we can ignore it. So that is what my things is going on in my mind. So this is the 5 days agenda for 40 hours. Okay, so many things I will miss out. So if you want to cover in detail also, yesterday I talked to Raju yesterday night. So he said like we'll have a detailed sessions also after once the 5 days is over. So that is stuff. So you can discuss internally and find out the ways for doing that. Okay, so installing Kubernetes. Now guys, let me tell you here, there are more than 40 methods which is available for installing the Kubernetes. More than that. Okay, so different platform, different method to install the Kubernetes. Okay, so EKS is there, GK is there, AKS is there, COPS is there, Kind is there, KubeADM is there, Minikube is there. Hell lot of methods are there. Okay, don't get lost. Any method, installation method you use it, ultimately you get the same software. Only the platform changes and installation instruction changes. Okay, so which component? So let me finish this also. Component, Kubernetes components. Okay, or we can call it architecture at a high level also. So what are the components? So guys, in every architecture, if you look at this, we are having human, means us. We are the person which drive the everything. And then here we have workstation. I call it workstation. Many people call it different workstation. And then here we have a Kubernetes cluster. So I will work in the workstation, which is my laptop, and laptop to Kubernetes cluster. So this communication you understood? Now let me tell you, this is the end user. No, this is not end user. This is upstream communication. I repeat, this is upstream communications. You are ops, human ops. Make sense? All of you? Hello?
Yeah.
Okay. Now, what then you'll say, Rajesh, can you tell me in workstation, means your laptop, what we have? What we have? So here in workstation, you have a kubectl. There will be one utility installed. I'll show you that one. In workstation, you'll have a kubectl, and kubectl refer the one file which is called kubeconfig. Okay, this is the file. Okay, kubeconfig file. In this file, you have all the access of the cluster config file. So this is the executable. This is the file. Workstation done. That's all you needed. Now, in the Kubernetes cluster, what you will have next? You will ask. So in the Kubernetes cluster, you have a master server. Okay, master node we can call it, and then we have worker node. Okay, so master node, worker node. So master node, we do have a multiple component. Which are the component? So one of the component which we have API server. Another component is we have a scheduler. Another component we have etcd. Fourth component we have a controller manager. Fifth component you have a proxy. Sixth component you have a DNS services and stuff like that. So these are the software running in the master node. Okay, these are the software running the master node. So there are some tools also there in the cluster. What tools? So the tools has to be there in each cluster actually. So some of the tools which is there is kubectl, then kubelet you have it, then kubeadm you have it, then docker you need to have, containerd you need to have, CNI you need to install. I'll not add too many complexity. So these are the tools need to be installed in the master node. See, the workstation only kubectl you need it, but in the master node, these are the tools you have to install it. Manually also install it using YAML or APT also you can install. So now in the master node, these tools will be there and this application has to be running. And this application, these tools has to be there in the worker server also, worker node also. That means the tool sets for the worker node and master node is the same. Don't you think so? Correct now?
Yes.
But in terms of services, you need to have this one, proxy only on worker node. Okay, so let me draw pictures, it will be easy for you. So here, this is you. And this is my laptop. I mean, operation. I'm operations team. Okay, and this is the clustered. And the clustered, you have a master node, and then you have a worker node here. So worker node, basically the application containers running. So here you have applications containers running. So in the master node, the most important service is API servers. This is the one. You know what? This is the most important services. What we call it API server. So here in the laptop you have a kubelet. Kubelet talk to API server, and all other component also talk to API server. Everyone talk to API server. So this is the one of the major component. Are you understanding, all of you?
Yeah, Rajesh.
So here APIs. So API server, basically we all talk to API server. We all means ops team also talk to API server, and internal component also talk to API servers. So that means this is the important component. So this is the front end of cluster. This is the front end of the cluster. Front end of the cluster. So what is this? This is a database. This is a database. etcd is a one product from the CNCF. This is based on the distributed store the key and value format. So this is the database of the cluster. So this is the application. This is all application. This is also applications. Only this is a database, stateful. These all are stateless. This is stateful. Okay. Now this basically you can say controller manager is like a monitoring mechanism actually. Monitoring mechanism for the clusters. So controller manager monitor entire clusters and update to the API server, and the API server stored in the etcd. So this is the controller manager, this is scheduler. This is scheduler, this is the controller manager, this is etcd in the master. 4 component I am right now talking. So what happens? You send the desired to API server stored in the etcd, okay, and then controller manager say, hey, this is the status of the cluster, report back to that, and API server will check that what you have in the etcd and what is reported by controller manager, and if mismatch, scheduler will go and schedule the work to the node, and in each node you have a kubelet. So here if you see that kubelet, each node. So kubelet is working like a agent. So if this is not there, that means this machine is not a part of the cluster. That means I was telling you, many regions, out of one region is like if kubelet is not responding, this is not a part of the cluster. So kubelet is running like an agent, and then Docker is there, another component which manage the things. So here scheduler schedule the work to the node, schedule work to node, worker node, and this is the networking services for the Kubernetes, networking services, and this is the DNS services for the Kubernetes. DNS services of the Kubernetes. So overall, this is the something which you have.
Rajesh, can we have that architecture diagram here?
Yes, very much. We can have it. So I'm avoiding that because it will become a full day of discussions. Only this one only. That's the reason I'm avoiding, because we have only one day, and I want you all to get into the hands-on in what is hands-on in the doing the Kubernetes, and then once you find the interest, you can read the more theoretical stuff. So that is my goal right now. So let me share with you. See, so this is something, the image I was trying to draw. So if you see that here, you have a kubectl which is in your laptop, and you can access to the dashboard also. Where the traffic is going, see Kubernetes master, correct? And then we have a Kubernetes worker, correct now? And the master, many components are there, but 4 these are important one: API server, scheduler, controller manager, etc. From the work master, the control goes back to the worker node. In the each worker node, you have a kubelet which is acting like agent, and here you have a pod. Just don't read the pod right now. Make it container for time, because you know containers. I have not explained you the pod, so I'll explain you the pod. And this is something. So just create an image of this in your mind, which will help you to understand. Are you understanding?
Yeah.
Yes.
Okay, now I'll show you the internal communication, which I was trying to tell you between this, how these components talk to each other. So just a second. Look at this. Don't get lost. Just see the arrow picture. Okay. So kubectl is my laptop. Okay. From there, I'm sending a request to API server. See, controller manager control entire clusters and update again to API server. And scheduler schedule the work to the node. And here you see anything you send to API server update to etcd. You see that here, database. This is the database, etcd. Okay, now if you look at this from the all this, the cube, because API server for internal, so API server, look at this kubelet, sorry, kubelet is agent here also. Can you see my cursor on a screen, all of you?
Yes.
Yeah. So kubelet, you see that it's a both the way communication. So kubelet is alive, so it keep talking to the API server, and any request you have API server, it's sent to the kubelet. So kubelet, if it is working, that means that worker node is a part of the cluster. It's not working, that's not a part of a cluster. Now here kubelet have a Docker also, and they manage the container. Pod I need to discuss with you, okay? And this is the upstream communications, internal communication of the cluster. But from outside, the internet means they will talk to the kube proxy. Internet means what? End user. So application is running in the worker node. I repeat, application is running in the worker node. But from outside, how people can access through the kube proxy of the node. This I'll discuss separately in the service section. So are you comfortable with the architecture at a high level? Again, each and every component in detail we have not discussed, but at a high level. All of you?
Yes.
Okay, so now these all slides you can get it, guys, on the portal, which location which is slides. Okay, so here Kubernetes, let's say here. So these all slides you can get it here. Okay, So now I was discussing something else. So you understand the component of master, all of you? And then worker node.
Yeah, Rajesh.
So if you want to set up, so if you want to set up a cluster, then you have to configure this workstation, your laptop, and you have to configure one master at least, and at least one worker. Okay, so far so good.
Yeah, Rajesh.
Now I'll do a little bit of tricking here. See here, in the master node you have a kubectl, okay, and in the workstation also you have a kubectl. So these two places you have kubectl. So what I will do, this file which I am supposed to create in laptop, I'll create in the master node itself. So master node will act like a workstation also. Understood?
Yeah.
So now after understanding all this component, I need to set up a cluster. So guys, so many methods are there to set up a cluster. Let me put it in this way. If you really want to understand step by step, then you should try this document. Okay, kubectl, and here CentOS. So you can try this one, kubectl CentOS 7, this one.
Rajesh,
Okay.
a small doubt.
Yeah.
Like kubectl is there, right? Utility tool. Like it will be out of master and worker node, or it will be in master and worker node also.
kubectl will be everywhere: workstation, master, worker. Why? Because
Okay.
if you look at this here, I said I will talk to API server, that's I'm human being, but internal component also talk to API server, no? Correct, no? So kubectl needed everywhere.
Okay.
Okay, so now guys, try this one in your leisure time, but I'm not trying this one. Why? Because there is a one latest version has come. There's a one upsetting thing actually. So Kubernetes 1.24 and Kubernetes 1.22. So you know what? Docker is dead. Did you understand this? Anyone?
Yeah.
So here,
More
what I'm trying to tell you here, if you look at all of my images, here you Docker, everywhere is Docker. So earlier the containers were run in the Docker with the Kubernetes. Okay, till 1.22. This is the one Docker. But 1.23++, they removed the Docker and with containerd. Got it? Containerd. That means next training after 1 year or something, or maybe 8 months and all, you can call me for the learning containerd. For time being, it is removed, but the real effect you will see after 8 months or 9 months, because of when you start transforming into the container. Okay, so this is the news. So what I am trying, so if you want to use the old version of Kubernetes, you can try with this one. But if you want to try the new version with the containerd, you have to try my another tutorial, which is just a second. Kubernetes install, just a second. And you have to try this one. This tutorial you have in Ubuntu. So you can convert these steps into the CentOS 7 also, but because most of us we are transforming to 1.2 from CentOS 7 is also dead. So this is also dead, by the way. So because that is dead, so I didn't feel like creating a tutorial. But it's all about setting up the cluster, whether you are setting in 1.2 or CentOS or somewhere else. All Kubernetes commands will be 100% same. Behavior will be same. Make sense? All of you?
Yeah.
So now what I'm going to do, I'm going to set up a Kubernetes cluster, latest version 1 lesser than that in the Ubuntu machines. So what I'm going to do, so guys, hundreds of script you have to run it. Manually running is like really a little bit time consuming and tedious, and if you make a one mistake, it will spoil entire effort. So what we have, all the script, I put it in one script, and that script I'll be running it. So this is for the master and this is for the worker. So I'm doing it. In fact, you'll be having recording for it. So you can do it offline, not during the session, offline, with a peace of mind. But right now, I'll just make it ready, a platform for all of you, so you can learn. Right now, learning a bicycle is important. Then comparing, you start learning assembling the bicycle. Okay, so first learn the bicycle, then you start become a mechanics and all. So here, Ubuntu. And I'll go for the 8 GB RAM. 2 machines I need, one for master, one for worker. 30 GB hard disk is sufficient for learning process. Name Kubernetes. And okay, my VM is ready. Rajesh, Mumbai. Okay, so this I'll make it one master, okay? And there's one more, I'll make it worker. Now master machines, which is here. This is the machine's IP address, okay? And worker is here. So 2 server I created on cloud, and it's a high-end machine, so you'll not have any problem. So now the question is, how do I access it? So I have a keys actually. Key is, which key I used, I forgot. So let me check this. Where's the key? I can't locate it. I'll search for
Rajesh Mumbai.
Rajesh Mumbai. Yeah. Thank you. So okay. So this is the IP address. Auth key PPK. I have it. And open. So I'll just improve the view for this, so you'll see better. 14, click OK, apply. And what is the username? Ubuntu. And here I logged in, I'll become a root. Okay, so now what to do? So I will go to, this one and check out this repository. Web also you can run it, by the way. Okay, but many of you wants to see the code. So this is the code. So this is the code, and here cluster setup, latest, This is the true script only you need it from this repository. Okay, so but directly you can run it, the command which I gave it to you in the chat. I mean in the here, this also it will work, but probably this one way you will feel little comfortable. Okay, and latest. And this is for master, this is for worker. So chmod 755 for master, and I run it, enter. So if you run in the 1 to 20, you will not face any problem. But if you run for the 1 to 18 or 22, you have to check that. 99% of the command should work, but except 1 or 2 changes, which again I had to validate. So all this script, if you want to read line by line the shell scripting, you have a script, you can go through this, understand the process. But right now my priority is to up and running and start using it, not teaching you the administration part of the cluster. Yeah, so guys, are you on my screen now?
Yes, Rajesh.
Okay, so guys, this command you have to note it down. Okay, this command, if you forget, then again you have to go to the fundamental of clusters. You have to understand it. You have to note it down, this command. Why I'm asking you? Because this command will be running in the worker node at the end of the cluster setup. So that means once you run this the worker node script, after that you have to run this command. This command only join the worker to the clusters. If you don't run it, it will not be there. Now if you go a little up here, see here, can you please read only this one? Only this one, the one which I selected. All of you please read it, don't ignore. And do let me know if you understood the concept of workstation or not. All of you understood or not?
Yes.
So here, remember that I was telling you what? Correlate the discussion. I was telling you, so you have a workstation, and in the workstation there's one utility called kubectl, and you need to configure the config file, right, at certain locations. So here what has happened, you can create this directory, and there is a file which is having some entry. Actually, I'm not explaining you right now, but this entry will configure your config file. You see here, copying in the same directory and giving a permissions. So this file, the moment is there, this file is there in any machines, okay, that will become a workstation, because kubectl anyways you have, right? Make sense? Hello?
Yeah,
Yes.
Rajesh, we have it.
Yeah, so like this, so this file is important. Okay, now what is in this file, what entry it can have, later on slowly we'll get into that, but right now we want to get into the user part of the Kubernetes. That means using the Kubernetes rather admin the Kubernetes. Okay, so right now few discussion I'm ignoring it, but you can read it again here. What networking driver I have used? So guys, there are more than 15 drivers which is available at this URL. Okay, but I have used as part of the script Calico driver. Okay, so that is the things. So anyways, yes, everything is done. My cluster is set up, guys. Can I validate my clusters? So some of the commands which I'm going to run it. Why this is confusing. So some of the commands which I'm going to run it. Let me make it bold so you can feel good. Feel good is also good. Yeah. So here kubectl get nodes. So you see here, this is my node name. I should have changed the node name, but it's okay. And this is the master setup and the version, which is this one, and ready. Now, if you want to change the version, guys, here this one. So what you can do, you can go and change the script also a little bit. I would request you to spend at least a day of reading this script. If you are trying to become an administrator, read the script. Okay. So here you can change this. I'm not changing it. The reason is sometime I am not try the those specific 1.24 in 1 to 2020. So that's the reason I'm not changing it. Why? Because sometimes it get failed, the demo gets spoiled. So again, you have to modify the script, test the script. So that is the process which we don't want to get into right now. So this is the stuff. Any questions so far?
No,
Uh,
Rajesh.
Rajesh,
Yeah.
is it always that we should go and do the installation with root user, or is it something
No.
like we should be doing it with
Sudo.
okay.
See, sudo, we all know that any admin work, admin installation, configuration, starting the service and all, you have to do the sudo. But I do sudo with all the command, or my bad habit is my bad habit. I become like this. So whatever you consider. Make sense?
Okay.
Yeah. So this is how I feel comfortable during the demo. And but all the policies, security practices, and all you have to bring in the production levels and all stuff like that.
Yeah, Rajesh, where does the Calico helps in this Calico?
Calico helps. So I'll put it in a way. So I'll remind you. So have you set up your laptop from scratch, install the operating system?
Right now, no.
Tell me. No. Since in colleges or maybe before that, did you install the
Yeah,
operating
yeah.
system yourself? Okay.
Yes,
Do you
yes.
remember? Do you remember after installing the operating system, you install the sound driver, VGA
Yeah.
driver, network? Do you remember? So tell me one thing. In your laptop, you install the networking driver also, right?
Yes.
Okay. So in your laptop, think and tell me. Think and tell me. In your
Okay.
laptop, Ethernet card was there all the time. But why do
Yes.
you install the networking driver?
Uh, like for giving
So why you are giving? Why
what?
you are installing the networking driver? Because you want the networking software, networking algorithm to be there, so you can talk over the network. You can send the protocol to the network, and you can receive the packets from the network. Right now.
Yeah, yeah.
Yeah, so something similar we have here also in Kubernetes. So Kubernetes, you have a networking devices. Which one? So can you tell me? I forgot. What is a network devices acting like a networking devices?
Proxy.
Proxy, yes. Here you have it. Answer yourself. So proxy is the networking devices, but it will not work. Why? Because it required the algorithm. So there's so many algorithms which we have in the market right now. So many algorithms. I showed you one URL on top. I lost that actually now. So I showed you one URL. So we have so many algorithms: BeaveNet, Calico, Flannel, CL2, L3. So many software are there. But Calico I used it. So the each pod, please hear me out. I use Calico. So each, what is a pod? I have not discussed, by the way. Let me put it in this way. Each container can talk to each other, and from outside also and internally also. So for that we need a Calico. Calico in Kubernetes we call it a network policy, but I said network driver. So both are same. So policy and driver something similar, which govern the networking traffic from internal traffic and external traffic. I mean over the network. Make sense?
Yeah, got it.
Yeah. Any other questions, guys? You have? Okay, let me show you some of the networking driver. So here, let me show you all these components, by the way. So kubectl get pods. What is the pod? I'll discuss. Okay, just give me some time. So name spaces. See here. This is the API server is here. etcd is here, controller manager is here, scheduler is here, proxy is here, core DNS service is here. These two are related to this one. What is it? Network. So this is a driver actually, Canal and Calico. So all these applications are running in your cluster. The same thing which I said, something similar here. So this utility you want to know which kubectl. See here, which kubelet, which docker D, which container D, see, and kubectl, right? Kubectl is missing. Kubectl. Are you understanding? These are the utilities actually, and these are the application services and all. Make sense, all of you?
Rajesh.
Yeah. So this note, please hard code this image, which I hard code. If you really want to become an administrator, you must go through my 30 hours of recording. I'll share the LMS locations with you. I'll discuss with Raju and then share with you. And if you guys wants to if you wants to have a admin session on Kubernetes, then again you can discuss with the Raju. He's planning for 15 more days sessions and all, so we'll help you with it. Okay, so now everything is done. Now guys, we'll set up a worker, and then after that setting up a worker, we'll get into the some sort of what do you say, demo for the services. So let me set up a worker quickly. I'll not explain it because the process is very simple. You know that by now. So here, new session. Okay, so here I'll not make it a bold this one because it is a worker. It should be difference. I have a bad habit. I must agree and accept. I like to be working in a root in a development environment, but in the production that I provide myself. So that is a habit. Okay guys, so my worker chmod 755. This will take a little less time compared to that one. because in a worker we have hardly few components, right? So I keep modifying this script. Actually, it depends on my training requirement. So for that I start writing the blogs also. I keep writing. If you follow that space, you will be up to date actually. So next the plan each in weekend, I'll try CentOS 8 and Ubuntu 22 with Kubernetes 1.24, which is the latest one. So this is a last month release only. I need a little bit time. Any questions meanwhile? Anyone have? I'm audible, right? All of you?
Yes, Rajesh.
Yeah, okay. Almost done. Remember that this command you have to run it in the worker, else this will not be a part of the cluster. Okay, so almost ready. Few more seconds and done. Okay, so now enter, done. So guys, my whole cluster is set up and ready to use. You can add as many worker you wanted. And now I'm just testing it. See here. Now it's not ready, but because it's installing this one, what is it? Driver. It just wait for a few seconds and now ready. So these are the commands I run in order to set up our clusters. I'll share with you in the notes. Okay, and done. Guys, any questions so far?
It was the same commands, right, which you have run for the master node?
Yeah, same command, only the see here, the difference is in the master node, these services will be created. In the worker node, these services will not be created except proxy. Proxy has to be there in each worker, each node, because it's a networking services.
So won't the proxy is also required for this master node? Yeah. So for every node, the proxy will be there. And how
Yes.
to check? There is a command, I think, right, to check all this where these
Yeah,
applications.
I showed you that command, which is get pods. You see here, two proxies there. Why? Because I have a two node right now, and two kernel is there because I have a two node here. This will be in the master only. Got it?
Yeah, yeah. But we are saying here something like pods, right? So kubectl.
I'll explain you. I have not discussed the pod. That is a point which is pending right now for me.
Okay.
Okay. Any last question before we go for the break?